Good afternoon, ladies and gentlemen. This is Taylor Burrows from DNN, Density News Network. Today's cool topic is the coolest topic you will ever find, literally, ice. Today we're going to learn about the importance of ice and its density and how it affects the ecosystems all around the world. Ice has been around for 14 billion years. Let's go. Next I'm going to show you Amanda Wong, this really cool journalist who knows all about ice and its density.
Thank you, Taylor. Hi, I'm journalist Amanda Wong, and I'm going to talk to you a little bit about the physics of ice. So let's do a little experiment, shall we? Here I have a regular cup of water, and here I have a bowl of ice. Let's see what happens when I pour this bowl of ice into this cup of water. So I'm going to pour the ice into the water. Wow, look at that. It floats. The ice floats. Why is this? Well, let's think about it. Whenever something is less dense than something else, it usually floats on top of it. And here, that must mean that the ice is less dense than the water. But since ice is basically the solid form of water, why is it less dense? Now I'm going to talk about why ice is less dense than water. Ice is less dense than water because of something called hydrogen bonding. The molecule of water is called H2O. That means it is made of 2 hydrogen, 1 oxygen. As you should know, ice and water are made up of the same molecules. So, what hydrogen bonding basically is well, everything in the world has a charge. Hydrogen has a charge and oxygen has a charge. And these two have different charges. Let's say hydrogen has a positive charge and oxygen has a negative charge. Well, we all know that opposites attract. So in this case, the hydrogen, when all these molecules are put together, the hydrogen element likes the oxygen element and they attract. However, if you put 2 of the same charges together, they repel. That means that the hydrogen molecule, the hydrogen element, repels against the other hydrogen element. This causes space. This causes they repel. And since we all know that temperatures with higher temperatures water is always less dense than cool temperature water. And however, when water is turned into a solid form, when it is so cold that this is all condensed together, so condensed together that the hydrogen and the hydrogen molecules want to repel against each other. And they all have to align in a way that the hydrogen always repels against each other, and the hydrogen is always attracted to the oxygen molecule, making it take up more space than water does. That is why, let's say that this amount of water, this small amount of water, when frozen up because of its molecules repelling and attracting and having to align in a way, it takes up more space. So that means that this small amount of water is equivalent to such a big block of ice. This causes the density of ice to be less dense than the density of liquid water. Thank you.
Thank you, Amanda. And we're going to take a little break from the show, but we'll be right back with the density of ice.
Adopt an orca whale, which depends on the floating sea ice to hunt. Adopt a polar bear, which depends on the Arctic sea ice in order to live.
And we're back with DNN's hot topic, ice and its density. Now we're going to talk about the density of ice and its ability to float on water and how that affects the ecosystem. Journalist Edward, take it away.
Thank you, Taylor. The density of ice is lower than water, which makes ice able to float on water, which is essential for the life of our ecosystem. To give you a simpler view, think about the Arctic Ocean. The Arctic Ocean consists of no land and only frozen water, also known as ice. Due to the fact that ice is less dense than water, making it able to float, it provides a surface for the Arctic ecosystem. Many organisms found in the Arctic Ocean that spends most of the time on the frozen ice would be the Arctic hare, the Arctic fox, caribou, polar bears, the Arctic tern, etc. All these organisms wouldn't be able to survive on the Arctic land if the ice didn't float, meaning they wouldn't exist here today. Another thing is, think about the temperate deciduous forest or any other type of ecosystem or climate that goes through cold winters. If the density of ice was actually denser than water, all the world's ponds, oceans, lakes, and rivers that go through freezing temperatures would not be able to consist any place, since if ice was able to sink, it would destroy and kill all the plants such as seaweed and riverweed. And since plants are also the main food for many sea and water animals, that means it would destroy all the food as well.
Okay, thank you guys. Is there anything else you would like to talk about?
Yes, another reason for why the density of ice is so important is because of the fact that since ice is less dense than water, it freezes up top, meaning the ecosystem below is still able to withstand life and its cold temperature and is being protected by the ice. If ice were to freeze at the bottom, this wouldn't be possible at all, and all the organisms and ecosystem would be.
Next up, journalist Amanda is going to talk a bit more about the glaciers and ice caps that are affecting our world today.
Only 3% of the world's water is fresh water, and 69% of this fresh water is being locked up in glaciers and ice caps, making it impossible for us to access this fresh water. The reason why 69% of the fresh water is being locked up and that we can't access it is because of the fact that ice is less dense than water, creating a frozen layer on top of this fresh water, protecting the ecosystem at the bottom of this fresh water, and not allowing us to access the fresh water. As said before, it is due to the density of the ice being less dense than water, causing it to freeze at the top, causing a layer of frozen ice at the top of these glaciers and ice caps. If ice was more dense than water, that would mean that humans would be able to access much more fresh water. However, it would also mean that we would be destroying the ecosystems that live in these glaciers and ice caps.
Thank you, Amanda. Thank you for watching today's hot topic of the density of ice, and hopefully one day you'll understand the importance of its density. Density is not useless, and it impacts so much of the world, so many of our ecosystems, wildlife, and human life, and has left an impact like no other. Please stop being ignorant and take care of your ice. Thank you so much for watching Density News Network, and have a good afternoon.